So today we are gonna look upon what exactly k-means clustering is with the example k-means clustering. Okay, so what is k-means clustering exactly? So let's consider a real life example. Let's say you have some data which will have the wickets taken by sportsmen. This can be either batsman or bowler, and it contains random data. Let's say hundreds of matches, and let's say tens and hundreds of players also. So we have a data set. We have to basically figure out that which of the people in the data set are bowlers and which of them are batsmen. So let's say you have a data set, okay, and let's say we have also one more parameter. Let's say we have to figure out that which wickets and runs taken by sportsmen. Okay, so let's say we have a data set and we have here in this axis runs and this axis wickets. Okay, and their data sets look something like this. This. Okay, this is a pretty standard example. Okay, now if just by looking, observing, what we have to do, we have to cluster or group, that out of which do you think looks like a batsman and which do you think looks like a bowler. So if I draw it pretty nicely also, that would help. So just look at this data set and tell me what do you think. So on just by looking, you can just simply say, okay, these people here looks like batsmen because they have scored a bit of runs, okay, and they have less of wickets. But over here, if you see these type of people, what you will see that these peoples are having more wickets and less runs. So it's give a bit of intuition that these people over here are batsmen and these people over here are bowlers, right? So this is what clustering is. We are grouping based on the k value. Here k value is what? 2. So I hope that gives you a pretty much idea about clustering. This is the simplest example I could think of and found this. How exactly it is working, I'll be showing you in the next slide. But for now, you just know that we don't tell, or we didn't provide any inputs that how to classify. We have just looked and observed and told us, say, okay, these people look like batsmen. Okay, these look like batsmen and these look like bowlers. So let's see how it's making clusters on it your own. So the only thing you have to define with the k-means clustering, that you have to define k. So you define k equals to 2 and you just give data to this model, and rest of the thing will be taken by k-means clustering. So how it's working, let me show you and do it practically. So okay, let's say this were our data points. These were our data points. Okay, this. Okay, now first step in k-means clustering is to define what's called centroid. Okay, centroid is you might have learned in mathematics. Centroid is a center point of anything. Like for example, you have a triangle, you have a centroid. For any other figure, like any polygon, you have centroid. Centroid is basically in something in the center. Okay, so since we have k value equals to 2, the first step is to define a centroid. So let's say we have our one centroid here and another centroid here. We are just randomly assigning centroid. We are just randomly assigning the centroid. Okay, now after that we will see that which all points are close to this centroid. So we can see this point is close, this point is close, this point is close, this point is close to this. And on the other hand, these points seems closer to this centroid. So what we can conclude from here is that these all points belong to certain class, and the remaining these belong to other class. So we have successfully classified our points in the first iteration up to this extent. Well, now next what we have to do, we have to change the centroid. Change one. First step was to randomly assign the centroid. Second is to update the centroid. This was the first step. Second step was to update the centroid. So how will be updating? Let's say we have these points in our class 1 and this is, let's say, class 2. So we'll be taking average and putting our star at the center point of all the averages. So our new centroids will be this. I think up to here it will be clear. And since it was a very simple problem, not all the points were what we say overlapping, so it happened in only one iteration. If it was a complex data set, we have multiple clusters and multiple points at the same place, we might have to look upon that how we are approaching this problem, and we have to do this process iteratively. So first randomly assign the centroid, then calculate the points which are close to that centroid. Third, you have to update the centroids based on the average of all the points in the cluster. Now after updating the centroid, what will you be doing? You will be again running the same process for calculating the distance from the centroids, and if there is some point, let's say there was some point here that was initially in this cluster, but after change of the centroid you found that okay, this point is closer to this cluster, so you would have updated your cluster to this and remove this cluster, this point from this cluster. So this is a very simple approach. So what we are doing, placing similar objects together. Okay, so this is the basic idea behind k-means clustering, and we are separating this similar object. Okay, now let's move ahead, and what we'll be looking, let's look upon that. We'll be looking on the topic like types of clustering. Okay, we'll be looking what is k-means clustering in a deeper look and a k-means clustering. Okay, next applications we'll be looking. Next we'll be looking at the common distance measures, and after that we'll be looking at the algorithm, and finally we'll be doing practical using Python. So these all are the steps which we all will be following during the learning process. Now let's move ahead and see upon types of clustering, because I just initially gave you about supervised and unsupervised learning. Now we'll be looking at the types of clustering, and let's see what all difference do they have. Okay, so let me just diagrammatically explain you what type of clustering is here. So so we were looking at the types of clustering. So first we have clustering. Now there are basically two types of clustering. One is hierarchical and another is partitional. Okay, and into that There is what? One is agglometric basically, and divisive. And in partitional, we have k-means, what is the topic of our discussion, and fuzzy c-means. Right. So clustering. Uh, so hierarchical. Let's first look at hierarchical clustering. So this division, all the decisions are basically on the thing that how you are representing the clusters, that how they are related to each other. So first one is hierarchical. So it's as its name suggests, how hierarchical. It might be something like tree-like structures. Okay, that they are related like this. So this is what hierarchical clustering is looking like. So let's say uh, you have two types of hierarchical clustering. You have two types of hierarchical clustering. One is agglomerative and another is divisive. So in agglomerative clustering, you have structure like, let's say you have let me draw it for you: A, B, C, D, E, and F. So now you are making clusters. Let's say you clustered B and C here together, okay, and D and E together, and let's say you have D, E, and F together, and now you have B, C, D, E, F together again, and at the last you have A, B, C, D, E, F. So you see, here comes a tree-like structure. This is what? Agglomerative clustering. It looks like this. You are just combining and combining. You are clustering it. So at every stage you have different set of clusters, a different type of clusters. Okay, so this is called agglomerative clustering in a nutshell. Now next we have what? Divisive clustering. So in divisive clustering, at the top, it's just reverse of agglomerative clustering. At the top you have one giant cluster and you are just dividing it. Let's say you divide it into B, C, D, E, F, and here you have B, C, here you have D, E, F, here you have again A from here, B from here, C from here, and D, E, and F from here. So this is what called divisive clustering. So I think that's pretty much about divisive. Now next, our topic of our discussion, it is called partitional clustering. Partitional clustering. So partitional clustering is like you have two types of partitional clustering. First one is k-means. So let's say k-means, how it looks like. We have already looked, but just have a look again. Just let's say these are some points, these are some points, and you make clusters like this only. This is one cluster, and this is another cluster. So here, what is the k value? Here, what is the k value? Tell me. It's k equals to 2. Okay, k equals to 2. So now what's fuzzy c mean? The only difference fuzzy c mean is that let's say these are our data points, and after classifying you make clusters, and this is fuzzy c means. So can you observe what's difference? If you make a keen observation, you find that okay, some of the points are overlapping. Okay, so this kind of thing is permissible in fuzzy c means, but it's not happening in the k-means. K-means make distinct boundaries and fuzzy c-means have overlapping boundaries. Now what next we have to look? We have to look next what's called applications of k-means clustering. Applications. So for the application parts, there are 4 primary applications of k-means. First one is for academic performance. Second application is diagnostic system. Third one is search engines. And fourth one is wireless sensor networks. Okay, so let me just give you basic examples of these 4 before moving ahead. So what in the academic performance, let's say you have a data set. Okay, the people are scoring different marks, and you want to classify that whether these people are good, very good, bad, or what else. Okay, so this kind of thing you can do with the k-means clustering. You can make let's say you take k equals to 4 clusters. So this will be dividing your whole class performance into 4 types of classes. Okay, four types of categories. So this can be done with the help of this. Diagnostic systems is like you have let's say you have multiple uh, X-ray images, and you want to cluster that which all images contains diseased X-rays. So that kind of thing also can be classified because they might be having some or other difference. Or you can say one example is like you have RNA or DNA strands. So you want to classify that which all genes or which all RNAs or which are DNAs belongs to some class, some kind of people, some race of people, or whatever. So these kind of things can be achieved with the help of k-means. Another is the search engine. Search engine, how you can say that search engines, what it do, it takes your input, you takes your search query, okay, and it tries to match all the similar things. So what we have learned here, that what k-means is doing, it's placing the similar object together, placing the similar objects together, right? Similar objects together. So this is all happening in the search engines also. You let's say you searched an algorithm, let's say you search k-means, so it will do what? It will search all the things which are related to k-means. And another thing is the wireless sensor networks. Okay, so this is another example of it. Now let's move to next topic, which is a very of prime importance in this distance, which is called distance measures. So why distance measures are important? I have already told you what we are doing in k-means. Let's say we have these all points here and all points here. And in the first step, what we were doing, we were assigning some centroid. Now, how we classify that say this point belong to this cluster? This is based on distance, na? Or let's say this point. So this is based on what? Distance. This is based on distance. So distance is very important parameter in learning the k-means and in the algorithm. So next we'll see what all kinds of distance measures we use. So let me first list them down and we'll then look at the mathematical formula of these. First one is Euclidean distance. You might be familiar with, you have learned and used it in your high schools or even the colleges. Second is Manhattan. That is also very famous way of representing distance. Third one is squared Euclidean. So it's just the Euclidean which is square. Fourth one is cosine distance. There is one more which is Markovnikov distance. This distance, it doesn't plays very much role in the most of the applications, so we just try to not discuss on it. We'll look at these 4 examples. Okay, so here first we'll just look at the what is Euclidean distance. So I'll try to show you diagrammatically. So first one is what? Euclidean distance. Euclidean distance. Okay, so this is our data set, and let's say not data set. Basically, these are 2 points. Let's say this is one point Q. This is another point P. and we want to calculate the distance. So in high schools we learn it that this is at, let's say, x1 y1 point and this is x2 y2 point. So what we'll be doing for calculating distance, we'll be applying distance formula, that is the Euclidean distance formula, x1 minus x2 whole square plus y1 minus y2 whole square. I think this is clear, you all know, so I don't want to waste time over here. Second one is squared distance, squared Euclidean distance. So what difference would we be having? Squared Euclidean distance. So what? Just let's say these are your 2 points, same x1 y1, x2 y2. Squared Euclidean distance will be what? x1 minus x2 whole square plus y1 minus y2 whole square. Same formula, but the square root is removed. Nothing much different. Now next is Manhattan distance. Manhattan distance. So let's say these are your points. Let's say this is your 1 point, this is your another point. Let's q x comma y, x1 comma y1, let's say, and this is p x2 comma y2. So how will be calculating distance? First you will be moving in the x-axis, then you will be moving in the y-axis. So up to here, this is what? x1 minus x2, we'll take mod, and here we'll be doing y1 minus y2 mod. So the whole distance will be what? x1 minus x2 mod plus y1 minus y2 mod. Let me write this clearly so that you can read it properly. It's what? x1 minus x2 mod plus y1 minus y2 mod. Okay. So that's up to the Euclidean distance. Now next, Manhattan distance basically. Next we are looking at cosine distance. So this is also, you might be familiar in the high school, cosine distance. So how cosine distance look like? If you have this p q, so what you will be doing? You will be calculating angle from the origin. So how you will be calculating angle from the origin? You will be drawing one line here, that's not very straight, and another line. It doesn't looks very good here. I'll try to make a good line, but I'm not able to. Okay, let's say this is one line and this is another line. Let's say we have any line thing here. No, we don't have, don't worry. So, and we'll be calculating this angle. This is, you can say this is very easy to calculate, that you have your dot product formula, a dot b equals to ab cos theta. Okay, so how will you be calculating as angle? Cos theta equals to a dot b divided by modulus of AB, right? Okay, this is the formula for the dot product. So you'll usually calculate theta equals to cos inverse dot product divided by AB. I think this is not a big of a deal. So this is what cosine distance is. So this is all about distances, and now in next video we'll be looking at how k-means clustering work. Okay, so thank you up to here. Thank you, and see you in the next video.